In this video, I'm going to show you how to do the video analysis on the spider, which is just a little bit more challenging. But you know, you're a good student, so you can do it. So the first thing I'm going to do is you run Logger Pro if you haven't done that, right? And then you're going to insert. You have to do this on a PC too. Okay, you're going to insert a movie. Okay, and it'll always take you to some folder where you don't want to be. Click desktop. For me, it's on the desktop. Okay, and then I want to find the spider. Okay. So I think this is the one that's of the spider. Yeah, there we go. There's the spider right there. That's what we want. Hopefully you've got a movie of the spider and your movie's not too bad. Now what I like to do is take this and make it nice and big. Okay. And then our distance reference on this, let's take a look. Let's go back to here. Okay. Let's go here. Go to Oaks Park. Right. And then click on spider. And I think the distance reference is that we know that that's about 2.04 meters, okay, is that fence. So if you got that fence in the video, you're in luck. If you didn't, you know, we'll just have to, we'll make do. We'll be able to do it, okay? So 2.04 is what I'm going to use. So let's go back here. Okay, and the first thing I'm going to do is I'm going to click this little thing right down there, and that opens up the tool palette. Click on this, and then this distance here is 2.04 meters. There we go. And now let's just play the video here and see what it does. I think what I want to do is I want to get that spot where it's coming down. Okay, this is good, right? So look at that car there. It seems like that car is gonna, whoops. Seems like I can keep my eye on that car. And it goes downward. Right, so let's go. I want to catch it going up to the top and stopping going up, right? When it stops going up, it's accelerating down. Okay, I think I've got it now. So I'm going to click on this. And this is what I want to click on, is that guy right there. Now I know it's moving to this side as well. But we're going to ignore that because that's the sideways motion is not generating vertical g-force. And it's the vertical g-force that we want to match. All right, here we go. This is hard to do. All right. So, I'm just kind of using that thing I've been clicking on has gone out of sight. So I'm sort of clicking on where it was, you know. It's like some imagination is needed. Okay, let's see. Do I know any more jokes? Okay. Okay, oh, this one atom says to another one, hey, you know, I feel like I've lost one of my electrons, right? And the other one says, that's not likely. Are you sure? And the first atom says, yeah, I'm positive. You get that? It's funny because, see, if an atom loses an electron, it has a positive charge to it. All right. So I'm just trying to follow that car through whatever its cycle is. Side to side, it don't really matter. It's the height of the car that matters. And you'll see that this loop-de-loop that it's doing generates just fine g-forces. All right, so I've got this is a downward acceleration. This is an upward acceleration. Let's take a look at this. We don't care about the x. It's the y that we care about, okay? So there's our y acceleration. And what I'm going to do is I'm going to select this. And I'm going to click, so select the data, the nice curvature. So this thing right here, this is a downward concave. So this is downward acceleration. Even though we're going up, we're accelerating down, which is kind of crazy, right? And then this is an inflection point, and then this is upwardly concave, right? But let's grab this chunk here. This is definitely downwardly concave, okay? I'm going to click that, and you want to do the AT squared plus BT plus C formula. And just try the fit. Oh, looks pretty good. All right. That's fun. Yeah, that's a reasonable fit. Now, take a look at this. See that little coefficient A? The formula really is y equals 1/2 AT squared, right? That's little a, like as in A is acceleration. This A here is just a coefficient, okay? So that big A, that capital A, is half of the actual acceleration of this thing, right? So if half the regular acceleration is negative 1.4 roughly, right? Then all of the downward acceleration is negative 2.8. So take that number, that 1.32, negative 1.392, multiply by 2. Take that coefficient, multiply by 2. It's negative 2.784 would be this downward acceleration. And then here is an upward acceleration, basically from here to here. By the way, you don't have to include it in the, you don't have to encompass it. You just have to cover it in the x direction. Okay, let's see. Let's try the fit. It already defaults to that, so try the fit. And okay. And this is an upward acceleration. It's much bigger, right? So that A is half of the acceleration. So the whole acceleration is going to be 2 times 3.077. So all of the acceleration is 6.158. Okay? So what you're going to do at this point is take a screenshot of this. You'll be on a PC, so you can do, I think it's Shift Windows key S, drag it across the screen, take a screenshot of this, put it in your slideshow, be able to talk about this, also be able to talk about your the data from your accelerometers. Okay? Yeah, there you go.